All right, everybody, we're going to go ahead and take a look at double angle and half angle identities. So this is kind of the natural progression after we do sum and difference. Now we talk about double and half. Very similar situations though, taking information we know about a particular angle and being able to express angles we wouldn't normally be able to do. So we're going to start with deriving those formulas, coming up with actually what they are by using something that you guys already know. So what I'm going to do for the sine formula, and we'll do the same for cosine and tangent, is I'm going to use a representation that we already know how to deal with. So if I write sine of double an angle, so 2 times theta is sine of theta plus theta, so 1 plus 1, that's the equivalent expression. It means the same thing. That means I can use the sum and difference formula to be able to write out that expression. So just look at your formula sheet and let's write out the sum formula for the sine of two angles. Now, so think of your alpha as a theta and the beta as a theta. That's kind of fun to say, your beta as a theta. So both of them are just the same angle, and that could definitely happen. Say they're both 10 degrees or they're both 15. So how that would look is sine of the first angle times cosine of the second angle, which also happens to be theta. If it's plus, it would be plus cosine of the first angle and sine of the second angle. And what you'll notice is these two terms, even though they're multiplied in the other order, that's commutative property, they're still the same thing. So we'd have 1 plus 1 of them. So that's going to give us 2 sine of theta times cosine of theta. All right, now that sine double angle formula then, if we know something about an original angle theta, I can use that information to help me figure out what twice the angle is. So we got a great option. So check on your formula sheet and make sure you can find that under the double angle part. All right, now for the next piece, cosine, we're going to do exactly the same thing. So I'm going to write it as theta plus theta and then use the cosine sum formula. Again, thinking of both alpha and beta being the same angle. So it'd be cosine of the first times cosine of the second, just so happens they're the same, and then plus, that means it would be minus sine of the first, sine of the second. All right, now when I do that, order of operations here, that would be cosine squared minus sine squared. And if you take a look on your formula sheet, you should see that one for the cosine of twice an angle. Now, when you look on your formula sheet, though, you'll notice that there's actually two other versions of that double angle formula for cosine. Let's talk about why. Take a look at the cosine squared part. If you look up in your Pythagorean identities, cosine squared is actually the same as 1 minus sine squared, and we can make that substitution. All right, so with that substitution then, everything would be in terms of sine, which could be an advantage when you're putting, when you're using these formulas and doing substitutions. So we have 1 minus, those are like terms, 2 sine squared of theta, and that would be equal to cosine of 2 theta as well. So we have another option, and if you look on your pink sheet, on your formula sheet, you should see that one as well. Well, I could have, instead of substituting for cosine squared, I could have done sine squared instead. So let's take a look at that version. So instead of substituting for cosine squared, I can substitute for sine squared, and sine squared of theta is 1 minus cosine squared. Now, you might have noticed when I wrote that down that I used parentheses, and that's super important because if you don't use parentheses, more than likely you're going to get signs wrong. You have to subtract both of those. So minus a negative would be plus positive, so you get plus 2 cosine squared minus 1. So just be super careful as you're looking at those signs when you make substitutions of expressions. So there's your third version. We have 3 different options then for cosine squared. So what might be an advantage to use the red one or maybe the blue one over the green one? Well, maybe you have a sine or a cosine, or that's what everything else is written in. Then we actually have something that we don't need to figure out something else. We're just using something we already have. So this is very much a kind of a personal preference or what might be most user-friendly. All right, let's take a look at tangent. We're going to do exactly the same thing. Go back to our sum and difference formulas. So that'll be tangent of the first angle plus tangent of the second angle over 1 minus tangent of the first angle times tangent of the second angle. We can do some like terms here. Those are like on the top. So 2 tangent and then 1 minus tangent squared. So again, tangent formula, we only need to know about the tangent of the angle. So there's your double angle for tangent. So those should all be on your formula sheet for you to use. All right, so what I'd like to do is go through kind of one start to finish with all 3 of the functions so we can talk about what's important to look for and then some of the things you need to consider. So let's talk about the angle first of all. It's really important to kind of start there. What do you know about theta? If theta is between 0 and pi over 2 or 0 and 90, what quadrant would it be in? Well, that's quadrant 1. So that means when I look at drawing my picture, I need to make sure that I draw a picture that the reference angle is in quadrant 1. Why do I care about the quadrant? Well, as you move from quadrant to quadrant, what can change? The signs, right? X and Y change signs. So when you substitute in ratios, you'll have to be keeping track of, is it a positive or a negative? So it's really important you pay attention to the signs. Okay, so then the other piece of information I know is I know something about theta in terms of the triangle. They told me the ratio for sine is 2/5. That means I know opposite and hypotenuse of that triangle. So the opposite side is 2. The hypotenuse is 5. So I can find the third side, then I can do whatever I want about that triangle. Now I know I don't normally show this, but I just want to make sure you're thinking about finding that third side. Don't assume you know the arithmetic. Make sure you're careful because you want to have the right side lengths in that triangle. So we get 21 equals x squared, square root each side. So technically, when you square root, you get two solutions, right? Plus or minus. How do I know if it's plus or minus? Go back to your quadrant. If I'm in quadrant 1, well, yep, I'm going to have a positive answer for that. It would be positive square root of 21. If I were in quadrants 2 or 3, and it's the x, then it would be negative. So the quadrant tells you if it's positive or negative. Okay, let's talk about cosine. You have 3 different options for this one, so that's why I wanted to start with this one. I want to show you some different ways to do the arithmetic, so please pay attention to that because what you choose arithmetic-wise might make your life a lot more challenging depending on how you're working with that. So taking a look at the triangle, the sine ratio is pretty easy to work with, the 2/5. The cosine ratio is going to be square root of 21 over 5. Maybe not quite as easy, right, to work with as we're talking about these. So when we're trying to figure this out and do our simplifying, it might be easier to work with sine. So I think a lot of people would probably start with this one, just because that ratio seems to look better. So let's go ahead and try it that way and see what happens. So if we substitute in for this one, it would be 1 minus, and here's where people mess up. That 2, it's a whole number. So when you write it as a ratio to be able to do this order of operations, it would be 2 over 1. A lot of people put 2 over 2. Well, if it was 2 over 2, it would be 1, right? So that's not 2. So be careful. It's a whole number. Put it over 1. Okay, sine of theta. So look at your angle for sine of that angle or that triangle would be 2/5. That's the one they gave you, right? Nice numbers, easy to work with. It's that ratio squared. Okay, so order of operations, we would do our squaring first. So that would be 4/25. Then next we do our multiplication, so 8/25. And then now you have to subtract. We have to rewrite that 1 and get a common denominator. That would be 25/25. So the cosine of twice an angle, do my subtraction here, would be 17/25. Okay, so let's first of all think if that's going to be a reasonable number. So our angle theta was in quadrant 1, right? We talked about that, so we know that that's a quadrant 1 angle. So I'm going to make sure that I'm thinking about that as a quadrant 1 angle. So if I double it, cosine of twice the angle, what happens to a quadrant 1 angle if you double it? Where could it end up? Well, if you know cosine of twice an angle is coming out to be positive, what do you know about your angle theta? It would have to be less than 45 degrees, right? Because if you double an angle less than 45, so pick a number like 40 and you double it, you get 80. It's still in quadrant 1. And that means cosine would be positive. So I can pretty much tell right now that this angle that I have, this theta that's represented by that triangle, has to be an angle less than 45 degrees. Because if it was bigger than 45, so just pick any number bigger than 45, still in quadrant 1, like 50, when you double it, you get 100. That's quadrant 2. Then cosine would have been negative. So it's really important to kind of think about what that looks like. Remember, you can go back to this original statement, right? And you could do the inverse sine of 2/5. And if you do that, try that on your calculator. It's about 23 degrees, somewhere in that ballpark. So yeah, doubled, that's 46. It's still going to be in quadrant 1. Okay, so I wanted to show you and kind of talk about that. But let's do a different version. Some people are not so keen on all the arithmetic you have to do with that. I want to show you another option that maybe might be easier for you. The top one on your formula sheet, I believe, is this one, the first one that we came up with. Cosine squared minus sine squared. A lot of people kind of shy away from this when the ratios don't look nice. I know cosine, if you do cosine ratio in that triangle, square root of 21 over 5, doesn't look very appealing. But let's just write this in here. Order of operations, though, what would you do? Well, you'd square, and what's the square root of 21 squared? Well, 21. And then 4/5 squared, or 2/5 squared would be 4/25. Do you already have a common denominator? Sure thing. And you get right to your 17/25. It's actually not that bad. And think about it this way. Will you always have a common denominator here? Well, if you're using cosine and sine, you're always going to have the same number on the bottom, right? It's over the hypotenuse. So that makes it really slick. So if that's easier for you, don't shy away from the one that's just both squared. If you have both of the pieces of information, it's not a bad way to go. Okay, let's try sine. So sine of 2 times theta. So this formula is 2 sine times cosine. So again, I'm just going to replace what I know from the triangles. Again, the 2 being 2 over 1, so be careful. Sine ratio is 2/5. Cosine was square root of 21 over 5. This is the same triangle, same information that we were using before, so we don't have to redraw. This one, even better. We multiply the numerators together, we multiply the denominators together. We don't need common denominator, it's just product. So 25 on the bottom. In the numerator, think of those 2's like your coefficient, 2 times 2. The radical is kind of like a variable, times the square root of 21. Can't really do anything with that. So that would be sine of twice an angle. So sine formulas usually people like pretty well. All right, tangent. For this one, I'm going to write out the formula first. 2 tangent over 1 minus tangent squared. We need to grab the tangent of this theta triangle. So 2 over 1, again, be careful. That 2 is a whole number, so 2 over 1. Now we need tangent. So I'm going to go back to that picture. My blue triangle here, tangent would be opposite over hypotenuse. All right, that's not that great. That's 2 over square root of 21, but that's what we're going to have to deal with. All right, and then on the bottom, 1 minus that same ratio squared. Okay, so let's check our arithmetic and see what we're doing here. So in the numerator, just multiply together. So we've got 2 times 2, square root of 21 times 1. Okay, not much we can do with that right now. On the bottom, we can square. So 2 squared is 4. This actually works out okay. Square root of 21 squared, that's just 21. Okay, so on the bottom, I need to subtract. So we're going to get a common denominator. So think of it as 21 over 21. So 4 over square root of 21 divided by 17 over 21. Now, we're going to have to multiply by the reciprocal. What some people recognize that this isn't very nice yet, and you're going to still end up, if we multiply by the reciprocal, with a radical in the bottom. So if you want to have smaller numbers to deal with, I would go ahead and rationalize that right away. We know we're going to have to do it eventually, so let's go ahead and rationalize. So that would be 4 square root of 21 over 21, and then I think that multiplication is going to be a lot easier for you to do. When you multiply by the reciprocal then, 4 square root of 21 over 21 times 21 over 17. The 21s divide out, and we get 4 square root of 21 over 7. And again, makes sense that all these are positive because remember, double the angle is still ending up in quadrant 1. So tangent of twice the angle would be 4 square root of 21 over 7. Let's talk about another option. What is tangent equal to? Look at the top of your formula sheet and give me an example or a ratio that tangent is equal to. Remember, it's slope. So tangent is equivalent to sine of the angle over cosine of the angle. So think about what we did prior to doing this tangent one. We worked through and figured out the answers for sine of the angle and cosine of the angle. So if you're already going through and doing that work anyway, and you remember this relationship that tangent is sine over cosine, if you remember, we had to do that sometimes in verifying, right? Because sometimes tangent isn't defined. You can't use the tangent formula. So you need to use sine over cosine. That's what tangent means. It might be faster. Let's peek back and see. The sine answer, oops, that's cosine. Sine was 4 square root of 21 over 25. So flip down here again. So 4 square root of 21 over 25 is the sine of 2 theta. Then cosine of 2 theta, that was 17/25. If you just have those numbers already, you know what each of these things are, you can just divide them then. That's what tangent means. And then you're right away to that arithmetic we were just doing. 4 square root of 21 over 25 times the reciprocal. And the 25s would divide out, and you're right back to 4 square root of 21 over 17. So if you're already doing sine and cosine, I guess for tangent, what makes the most sense to me is just divide then, right? Because that's sine over cosine. But if all you need is tangent, it would kind of be ridiculous to go through all the work to figure out sine first and then figure out cosine and then divide. So you know what? It's going to just depend on what you need to do. So if it's sine you're trying to figure out or tangent you're trying to figure out, just do it directly. So those are the double angle formulas. So we can figure out something about twice the angle because we know what the original angle is.